I think you can see the notes. Can you see?
Yes, sir.
Okay, okay, okay. So we had seen the definitions, the three definitions of the gamma function. Then we saw the other forms of the gamma function. Today, what we are going to do is very few problems, and complete the discussion on the gamma function. See, the first thing that we do, or the first problem that we do is this: del 0 to infinity x to the power 6 exponential minus 2x dx. Okay. Uh, this one we are using this. So this one is solved using this result. Exponential 0 to infinity. Sorry, integral 0 to infinity exponential minus ax, where a is a constant. X to the power n minus 1. This is equal to gamma n over 8 to the power n. Yesterday we had done this. There we had lambda here. Okay, lambda here. Instead of that, if we use a constant a, I will be getting this. So gamma m over 8 to the power n. Okay, or constant to the power n. Okay. So we are writing this like this: 0 to infinity x1 minus 2x. X to the power 6 is written as x to the power 7 minus 1. Like this. So we have this gamma 7 over 2 to the power 7. Gamma 7 over 2 to the power 7. Okay. Gamma 7, we know that is 6 factorial. So you will get this result 45 by 8. I think you have understood this, what we have done here. Okay. So in physics at several places we might be encountering with such integrals, such kind of integrals. So we can solve it easily using the gamma function. Okay. So here instead of n we have 7. Okay, so what we have is 2 to the power 7. So that's how we got this result. I think it is clear to you. Okay. Is this clear? Can I move on to the next question? Can you hear me?
Yes, sir.
Okay, 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 okay. Then another question, 0 to infinity. We have to evaluate this, integral 0 to infinity root y exponential minus y cube dy. Okay. So this integral can be evaluated using the gamma function. So here what we are doing is we are taking y cube. We are introducing a new variable, y cube equal to x. Okay. We are taking new variable x. So y cube equal to x. So 3y square dy, that is equal to dx. dy equal to dx over 3y square. Okay. So y equal to x to the power 1 by 3. Y cube equal to x. Y is x to the power 1 by 3. Okay. So dy will be dx over 3x to the power 2 by 3. Okay. So we are trying to evaluate this, and this is not exactly in this form. It's not exactly in the form of the definition of the gamma function. So we are changing it into the definition of the, or the form of the gamma function definition. So for that, I am taking this y cube as equal to x. I differentiate this, so 3y square dy dx. So dy will be this, okay. So here for root y is x to the power 1 by 3. So here for y I am giving x to the power 1 by 3. So I will get x to the power 1 by 6 e to the power minus x. Dy is this, dx over 3x to the power 2 by. So this I get, and there is no change in the limits. Okay, when x is 0, sorry, when y is 0, x is 0. When y is infinity, x is infinity. No change in limits. Okay, so I think this is clear to you, the transformation. This transformation, I think it is clear to you. Then I will get this 1 by 3, 0 to infinity exponential minus x. Here I have x to the power 1 by 6, here x to the power 2 by 3. So x to the power minus half dx. Okay, 1 by 3, 0 to exponential minus x, x to the power minus half dx. X to the power minus half is written as x to the power half minus 1. Okay, x to the power half minus 1. So what will be this? Can you say 0 to infinity exponential minus x, x to the power half minus 1 dx?
Gamma half.
What is this? This is gamma half. Okay, so 1 by 3 gamma half. So this is root pi by 3. Okay, so making this change, y cube equal to x, I am changing this into the form of gamma function. Okay, or gamma function definition. So root pi by 3 I am getting. Okay. Then the third one, this is quite easy. I have this exponential minus x here. X, root x. Root x is x to the power 3 by 2 minus 1. Okay, root x is x to the power half. X to the power half can be written as x to the power 3 by 2 minus 1. So this is gamma 3 by 2. Okay, gamma 3 by 2. See, x to the power 3 by 2 minus 1, exponential minus x dx. This is gamma 3 by 2. So this is half gamma half. So this is root pi by 2. So this is quite easy. Okay. Then see, 0 to infinity, we have to evaluate this. Integral 0 to infinity root x exponential minus cube root of x dx. Okay. So how can we solve this or evaluate this? Do you have any idea? See the problem, 0 to infinity, integral 0 to infinity root x exponential minus cube root of x. How can we evaluate this? Any idea?
Substituting cube root x for something y.
Yes, cube root of x equal to some another variable, say y or some t. Okay, so x cube root of x equal to t. Okay, so all of you try to do this, attempt this. X to the power, the idea is x to the power 1 by 3 equal to t. Okay, this cube root of x equal to another variable t. So x will be t cube, dx equal to 3t square dt. Try. Anyone got final result? Final answer? Anyone? Are you there?
Gamma 7 by 2 by 3. Sorry, into 3.
Gamma
Yes, sir.
7
3
by 2.
gamma 9 by 2. Correct. Yeah.
3 gamma 9 by 2.
Yeah.
Barna got gamma 7 by 2.
Gamma 7
Into
by
3. Into
yes.
3.
Into 3.
It is actually gamma 9 by 2 into 3.
No, small mistake is there. It's 9 by 2.
Yeah. 7 by 2 can be written as 9 by 2 minus 1. Okay. Here you will get t to the power 7 by 2. That can be written as 9 by 2 minus 1. Okay. So you will get 3 gamma 9 by 2. Then similarly you can do this. Then 0 to infinity x to the power 4 exponential minus x dx. This is the exponential minus x dx. This is very simple thing. Okay, you just write x to the power 5 minus 1. So gamma 5. And what about this one? How do you do this one? The sixth one. You may take down all these questions. 5. And the answer you have to get this. Okay. Then do you take down this 5 and 6?
Yes, sir.
Okay. Then 7, 8. Write down 7, 8. You have to get this answer. Okay, then 9 and 10. Take down 9 and 10. You have to get this. You know what are the substitutions that you have to make here for this minus 2x square? What are the substitutions you have to make? Exponential minus 2x square. Okay, so you have to do all these problems, 5 problems, 5, 6, 7, 8, 9, 10. Okay, answers are given and verify whether these answers are correct or not. I haven't verified. Okay, so have you finished writing down these questions? Have you finished? Okay. So you attempt all this and see other mathematical physics textbooks that you can refer to now through online and try to do the problems related to the gamma function. This is how the gamma function is varying. See, you know gamma 1 is 1, gamma 2 is 1. Here on the x-axis I have taken x, and on the y-axis gamma x. Okay. X-axis I have taken x, and on the y-axis gamma x. And this is how it varies. See, gamma 0 infinity. Okay. Gamma 1 is 1, gamma 2 is 1, gamma 3 is 2. No, okay. Gamma 4 is 6. Okay. Gamma 4 is 6, and it increases like this. Gamma 0 infinity. So, do you understand how this gamma function is varying like this? Variation of gamma x for positive values of x. Do you get this?
Yes, sir.
Okay. For negative values, it will be something like this. You can actually refer to the Afghan. I think it is available online. This is how the gamma x is varying for negative values. So in between 0 and minus 1, it is varying like this. Okay. In between 0 and minus 1, this variation is this. In between minus 1 and minus 2, the variation is like this. In between minus 3 and minus 2, the variation is this. Okay. This is how it is varying. Between minus 3 and minus 2. Between minus 1 and minus 2, it is like this. Minus 1 and 0, it is varying like this. Okay. So you refer to the textbook and note down how the variation, the gamma is varying with the values of x. Okay. So you try to do all the problems, and tomorrow we will be starting our discussion on the beta function. Okay. So we stop today.